as we finish off, hopefully today without interruptions for her to bark. I don't want those. We're going to start where we kind of left off yesterday, where we have multiple fractions. We need to get rid of the denominators because that's no fun to deal with. And so similar to what we did in number 7, this is going to be our little 2-step mini guide to getting those out of there. So, if I work through just looking at the denominators at the start, 2 is the only number down there, so I really don't have to do much. So just 2k. Yeah, if they all have the same variable or the same exponent, we only got to use it once. And so here, when I do my 2k, just like yesterday with the 6n, you're multiplying the 2k times the numerators. So you're like, okay, wait. 3 times 2k would be 6k. The denominator's still there for the moment, especially with notes. We want to see how everything's working. -1 times 2k would be 2k. We get that in there. And then 2k times 12 would be 24k divided by k. But here comes the nice part. Once we've distributed that through, if I've done things correctly, if I have my least common multiple right, stuff in the numerator should cancel with stuff in the denominator. Yeah, so I can have stuff go away. That's a lot better than what we started with. But do remember, there still is a -1 with that k. So when we get to the end here, we're not quite to the end. And again, that's not k minus 1. We're not adding 1. We're dividing by -1 and making sure, bless you, that plugging that k in doesn't cause a 0. Last I checked, -18 is not 0. So that one's okay. And I wonder at times if some of you are beginning to think that I'm just full of it when it comes to some of these answers not working. We're going to see one. We're going to see one. We are not doing number 9 for reasons that are only known to me. Basically, you're not going to see something like that on the quiz. So we're not concerned. We're going to go to 10. 10's got its own issues. So if I go to number 10, here's a first for us back here. When you're looking at your denominators, are any of them factorable? Okay, I can take a 3 out of there and have w minus 1. So I'm gonna cross out the old one because I want to look at it this way. And so once I've factored, and that would help me to make sure this number doesn't get too big. I'm going to pull this back down a little bit because I want to be able to see my instructions at the top. Okay, largest common factor. If we start counting by 3s and 9s, what's the first number that's showing up in both lists? 9. Okay, so we need 9. We don't have any single variables this time, like we did here with k or here with n. So we have one more piece of the puzzle we've got to add up here at the top. And that last piece is any set of parentheses that we see. Every one that we see that is different needs to be included. Bless you. But they're the same. So I only need to use one of them. So that's our magic value that we're going to be multiplying through by. Now, that can get a little interesting. Okay, let's chat. Okay, because I've got a 3 here and I got a 9 here. So if I start counting by multiples of 3 and counting by multiples of 9, Okay, the first number that shows up in both lists will be that. So, do I really want to have to write all this stuff up in the numerator? That doesn't sound like a lot of fun. So, there's two ways we can tackle this, and you're going to kind of figure out which way you'd rather go. Some of you are going to like the idea here, once I get a piece of paper that's skinny enough, there we go, that we'd cover up the other pieces, and what you would do is you would cancel stuff that you could in the denominator, and then you just multiply what's left up here. That's a little trickier. So I'm going to start the old way, and then we're going to see what we think. So if I start the old way, if I'm multiplying, so I'm like, all right, let's see here, 13 times 9. So 13 times 9 is 117.
So just to clarify, you get the 9W because of the 9.
And this 3. Yeah, because if I...
Because 3 is a multiple of 9, right? So,
9 is a multiple of 3.
yeah.
So, yeah, like it'll never be smaller than the largest number that you have.
It won't be smaller than the
Yeah, it'll never be smaller than that. So like 9 would be the smallest number possible this could be. It can't be smaller than that because that wouldn't make any sense. Like what can I multiply 9 by to get to 3? I'd have to divide. So when I'm looking at these, that's why I made these little lists and I started making the multiples so I can literally see what's that first number that's going to show up in both to try and figure that out. So we will be simplifying these. We will be back to them. But if I distribute, I multiply my coefficient. Parentheses are still there. Oh, this is going to get tight in a minute. That's all right. We'll be okay. And this W is outside. So we're going to have 9W. Oh, Hardy. You're like, oofda, that does not look simpler. It's going to, though, because once I distribute that, now I can zap those W minus 1s, and I believe 117 divided by 3 is 39. Fraction's gone. Okay. So all we did there was cancel the parentheses we have in common, and then just divided the coefficients that we had left, and it came out really, really nice. The second one's even easier.
Oh, okay, you're just looking at the...
Yeah. The W minus 1s cancel, just leave me with the 9. That's cool. And then over here on the right, the 9s cancel, and that W is still there, so I'm going to distribute the W. So W times W is W squared. Minus W. So the fractions are gone. That's nice. I'm not thrilled that I see W squared because I know what's coming now. So what's 39 minus 9? 30. So we're going to subtract that over. So this 30 that's over here, in actuality, we got to get it to the W squared side because, yes, the Algebra 2 F word is going to rear its ugly head. Got to do it. Got to do it. 5 and 6, I'm being told. So let's see. Negative 30, one will be negative, one will be positive. There's the sign of my bigger number. So negative 6 and positive 5. And now to actually get the answers, that would do it. It's just opposites. You're right. So negative 5 and positive 6. And just make sure. Negative 5 minus 1 get me 0? No. 6 minus 1 get me 0? No. They both work. that was probably the craziest one we're going to deal with. Okay. This next one. The 2 is in the numerator. So don't let the fact that it's not a fraction confuse you. You can put it over 1. That's fine. Here's the good news. I don't really need to do anything with 1. That doesn't change anything. I don't have any variables that are hanging out on their own, like number 7 or number 8. So my entire LCM is just x plus 3. Which is going to work real nice here, because I can kind of see what's going to happen when I start to distribute. I'm going to have x plus 6 that's already there, x plus 3 over x plus 3. Yes, the canceling you think is going to be there will be there. Here, yes, we still multiply it times the 2, even though there's not a lot of stuff working there. And then we do it on this last one to the 5x plus 12. We're not going to be multiplying or foiling this out, so don't go to the work of doing that. Because, right, all those x plus 3's that I'm seeing on the outside, here and here, just cancel. So out of all this stuff, the only thing I got to do is remind myself, this is a negative 2 right here because of that minus. So negative 2x, negative 2 times 3 is negative 6. And so now this is just going to become a whole bunch of combined-like terms and working around. But no x squareds. There is no factoring this time. Just be careful with your signs. Positive 6 and negative 6 cancel. Yeah. Where'd this come from? Aw, man. I put the equal sign in the wrong place, didn't I?
Yeah, you need equal sign.
Oh, all right, hang on. We'll fix it. Dadgummit. All right, hang on. It just had to happen. It just had to happen. Thank you. Thank you. All right, hang on. Let's do this right. Equals, Hardy. There's the equals. My apologies, people. We get all the multiplying right, but then I put the equals in the wrong place. That doesn't help anything. Okay. Let's play this game again. Well, no, I wish I wouldn't have gone bonehead. That would have helped things out a lot quicker here. So, okay, same stuff cancels. The distributing's a little easier now.
Your hand not get tired all day.
Over time, it just gets used to it.
My hand does not get used to it. I'm tired from writing in a single class period.
So now that negative just got distributed through. Now I can correctly combine the like terms. Again, watch your signs. That is as important as anything. All right, let's see here. I don't like dealing with negative x's, so I'm going to move my negative 3x to the other side here. And be careful here, too, because subtracting 6 from here is not going to cancel that out. It is going to make me need to write over here, though. (4x is negative 12. Divide by 4. X is negative 3. Oh, we may have a first. If I take negative 3 and I plug it back into the denominator, negative 3 plus 3 is 0. You can't divide by 0. It's undefined. That answer does not work. Our first no solution. That's about as often as they happen. Because if you take your answer and you plug it back into the original in the denominator, you can't divide by 0. So here, yeah, that minus that's there is distributing through. It changes the signs on both of those. So that's our rare case that we're looking at where we'd run into a no solution. So again, it doesn't happen often. Are we done? I gotta put one last crazy factoring one in. Especially since I went nutsy. Bonus. Okay, I'll be very directed this time so it gets done faster. What do we have in common in the first fraction here? C. So take out a C. All right, so that's not really there. Again, this 1, we're just going to make it a fraction. So I go through. The 1 doesn't help me, so common factor that way, I don't care. That C right there is a single variable, just hanging out. So that needs to be part of my LCM. And the one set of parentheses that I have, the C minus 4. That needs to be part. C minus 4. Oh my. So, through we go. Now, again, don't get caught up with how much stuff you're seeing here. We're not going to be multiplying all this stuff out. A lot of it's just going to cancel out. So just kind of, now you're like, Hardy, well, what about this? This is weird. Okay, C times C minus 4. Could I have made that C squared? Yeah, but it really wasn't going to do a whole lot for me here. Did I do it again? Oh my. I need a personal tutor to find equal signs for me here. Hey, at least we found it on the first step this time. I didn't get too far before chaos commenced. Oof, duh. Okay. Zap the C's. Zap the C minus 4s. So I got 3C minus 2. Zap the C minus 4s. C times C is C gulp squared. And this minus 1C, this negative that's here, gets distributed through. That's got to be good news, though. Negative C times positive C is negative C squared. Negative 1 times negative 4 is positive 4C. Why is Hardy saying this is good news? Because C squared minus C squared cancels. There will be no factoring on this problem. Yay. Let's get all the C's to the side that has a C already. 4 minus 3 is 1. Does negative 2 cause a problem? Negative 2 minus 4 is not 0. Yay. That works. So, yes, it does get a little crazier with the 3 fractions, but in reality, once we distribute, we're going to cancel it all out anyway. So we're not really too concerned about that to be perfectly honest. So that's it on the hardy gibberish front. So reminders, especially if we didn't get to some of the things yesterday. So today we are rolling over on page 10, the back of yesterday's sheet. We're rolling through those 9 to 14. At least get yourself 3 or 4 of those because it's going to make the quiz preview tomorrow and the quiz itself Friday. Sure. Because if I'm remembering correctly, and don't quote me, I believe there's four questions like yesterday and today, and 4 graphing questions on the quiz. That sounds about right. I'm pretty close. It's not going to be a real long quiz. At most, it's 10 questions. But I think it's 8. So, play with those again. Keys are up. We will work through the review together tomorrow to kind of let you see what that's going to look like. And